హాయ్ ఎవ్రీబడి, వెల్కమ్ టు ఎస్ఎంఆర్ తెలుగు ఎడ్యుకేషన్. ఈ వీడియోస్లో మనం సి లాంగ్వేజ్ పాయింటర్స్ కాన్సెప్ట్ డిస్కస్ చేస్తాం. సో నెక్స్ట్ టాపిక్ ఈస్, సో లాస్ట్ వీడియోలో వీ హ్యావ్ టు డిస్కస్ వాట్ ఈస్ ద సైజ్ ఆఫ్ పాయింటర్. సో నెక్స్ట్ కాన్సెప్ట్ ఈస్ వాట్ ఆర్ ద ఆపరేషన్స్ allowed on pointers. Operations on pointers. So here I am taking the small example. Here the pointer p1 is equal to, pointer p1 is one integer type of variable. Here I am taking another pointer variable p2. P2 is another integer pointer. So P1 is one pointer, P2 is another pointer. Here I am taking P1 value is 500 and P2 value is 600. Here I am adding two variables, pointer variables, P1 plus P2. P1 plus P2, then we will get an error. So addition operator is not allowed in between pointers. Whenever you try to add two pointers, we will get an error. So P1 is, if the P1 is one address, P1 is one address, P2 is another address. So P1 and then P2. So addition is not possible, then we will get an error. I will ask you one question. Your next address, whenever we are adding pointer to one value, it represents next address. That means next address of the P1 is one variable. We have to add one means we are next address value, that is next address. For suppose in integer the size is 2 bytes, the first byte is first address is 500. We are adding plus 1 means next address is 502. Next, addition of one value is allowed. Next, P1 plus 2 allowed. Next address, next address. Next, P1 plus P3, 3. That means next two values allowed, valid. P1 plus some x. Alamanu, you have to add continuously up to somewhere you have to get P2. Some address in middle. Okay. Next, from this equation you have to write P2 minus P1 is equal to x. So can I subtract P1 minus P2 is equal to some x. That means in this some addresses are there. So this one is P1, this one is P2, this address is P1, this address is P2. Whenever you have to subtract these value into this value, it gives the remaining elements in between P2 and P1. So the subtraction of pointer variables is allowed. This one is valid. It gives the elements in between P2 and P1. Okay, in arrays concept, in arrays and strings, we are using all these operations. So addition of two pointers is not allowed. Whenever we are adding one value, we will get the next address. We are adding so we are adding 1, it is pointing to this address. Next we are adding 2, we are pointing to this address. We are adding 3, pointing to this address up to some addresses, then we will get the P2. The difference of P2 minus P1 gives the addresses between P2 and P1. Next, so can I subtract one value from the pointer? So P2 minus 1, this is P2. Whenever we are subtract one value, it pointing to previous address. So P2 minus 1 means this value is pointing to this address. Next, P2 minus 2, it is pointing to next address. Okay, so can I add one single value into pointer? Yes, it is pointing to next address. Can I subtract one value from the pointer? Yes, it is represents the previous address. Can I subtract two pointers? Yes, valid. It gives the number of addresses in between the P1 and P2. So these are the operators allowed on pointers. Next, can I multiply one value pointer with a single constant value? So P1 into 2, this is invalid. So we will get an error. So can I subtract one pointer into another pointer? Sorry. Can I divide one pointer into another point? No, not allowed. Not valid, invalid. This one also invalid. So can I divide modulus of one pointer to another pointer? Invalid. So can I divide one single pointer into a constant? This is also invalid. So these are the operators not allowed on pointers. The only allowed pointers. So then I compare two pointers. P1 is double equal to P2. This one is valid. So both addresses are pointing to same value or not. It will check P1 address and P2 address are both are equal or not. This one is valid. So these are the only operators allowed on pointers. So plus 1 plus some constant value. Plus 1 is pointing to next address. Minus 1 is pointing to previous address. And then double equal is allowed to compare the two pointers. Multiply with constant value, divided with the constant value, modulus operators, these are not allowed. So by clearly you have to understand this with an example. So void main. Here I am taking long int variable, long int size is 4 bytes. Here I am taking hexadecimal representation is start with 0x 1 2 3 4 5 6 7. Here I am taking character pointer char. PTR is equal to address of long int some variable name a is equal to, this is the value. So char PTR is equal to address of a. Here I am adding PTR plus plus. So PTR plus plus. So in this here we are adding plus 1 means plus plus increment operator is equal P1 plus plus is equal to P1 plus 1. P1 minus 1 is equal to P2 minus 1 is equal to P2 minus minus. So subtraction is allowed and addition is allowed. Subtraction gives the next address. Sorry, addition gives next address. Subtraction gives previous address. Same printf percentage x for hexadecimal form asterisk PTR. Right. So the size of long int is 8 bytes. The memory is allocated for 8 bytes. 8 bytes. Here I am taking, this one is the first byte, this one is the second byte, this one is the third, this one is fourth. Here I am taking the addresses 500, 501, 502, 503. 502, 501, 500. So this is hexadecimal representation. 78 is stored in binary form, but here I am writing integers. 7 is 0, 1, 1, 1. 8 is 1, 0, 0, 0. Similarly, 5, 8. Directly I am writing integer value is 5, 8. 5 is stored in 4 bits. 6 is converted into 4 bits. So better to write so 5, 0, 1, 0, 6, 0, 1, 1, 0. Next, 3, 4 is stored into 3. Stored in next byte. 3, 4 is 0, 0, 1, 1. 4 is 0, 0, 0, 1, 0, 0. So similarly, 1, 2. 1 is 0, 0, 1. 2 is 0, 0, 1, 0. So these values are stored like this in the memory. Next, what is size of char is 1 byte. The size of character pointer is 2 bytes. Here the memory is allocated. Here variable name is A. Here the variable name is PTR. So PTR, some address I will take 600. So in PTR is equal to address of A. What is A? This one. What is the address of A? The base address of A. Base address of A is 500. This 500 is stored in this variable. Right. Next. So here we are using PTR plus plus. That means the pointer is pointing to next address. What is the size of char? Is 1 byte. Whenever we are using the character pointer increment, the character size is 1 byte. That's why whenever this statement is executed, this value is replaced with 501. 501. Now this pointer is (501). So character next, the PTR plus plus means the pointer is pointing to next address. That next address is 501. Okay. Now once again we are using, once next this statement is executed, PTR plus plus. That means the pointer is pointing to next address. Next address is 502. This one is replaced with 502. Now this pointer is pointing to 502. Next, this statement is executed. Printf %x. %x is hexadecimal form. Here PTR means 502. Asterisk PTR means 502 address value. That is this value. This value is 3, 4. So output is printed 3, 4. Okay, I have to run this code. So I will take new file. Save this file with .c extension. So operate some name .c. Here I am taking void main. So long int a is equal to 0x12345678. This is hexadecimal. So char asterisk ptr. So ptr is equal to address of a. So ptr plus plus ptr plus plus. Printf %x star ptr or asterisk ptr. We have to run this code. Here I am clear the screen. CLR SCR. So I have to run this code. So output is 3, 4. So alt F9. Yes, warning. Warning is not a problem. Here we are assigning long int pointer to here long int pointer, long int variable address to character pointer. That's why we will get a warning. No problem. Next, run this code. Alt F5. Control F9. The output is alt F5. The output is 3, 4, 34. Okay, right. So instead of here I am taking character pointer, you are take integer pointer. I am taking just one ptr plus plus. Now the size of pointer is 2 bytes. That's why whenever we are incrementing ptr plus plus, in this case here we have to change integer pointer. Integer size is 2 bytes. Now we have to take this one is the first byte, this one is the second byte. Whenever we are incrementing the integer pointer pointing to next address. Next, this value is printed. This value is 1, 2, 3, 4. In this case, you have to run this code. The output is 1, 2, 3, 4. Alt F5, 1, 2, 3, 4. See, the concept is what are the operators allowed on a pointers. Okay. Whenever you have to increment the pointer, we will get the next address. Whenever you have to decrement the address, it get the previous address. So thank you for watching.